I think with that, we'll hand it over to Vincent for the first tutorial. So yeah, this we have 53 minutes, almost exactly took back your time from yourself. So yeah, I'll hand it over to you, and then the next hour will, I think, Stack comes after that.
Cool. Thanks. All right. So I try to stay on time this time, and feel free to interrupt me whenever. So I'm going to talk about COGs and like quite of a deep dive in COGs, and so what to do with them, what not to do, what makes them good, what makes them bad, and what kind of tools I usually use. Is it okay? Okay, I got feedback. So anyway, cool. Okay, sorry. All right. So yeah, it's like so again, it's still me. So first, to repeat what Jed said, COGs are not magical. They are just GeoTIFF, and that's what makes them great, because they are compatible with almost all software that supports GeoTIFFs. And should I do just that? Right. Cool. Yeah. So there are like GeoTIFF, just a better optimized, better organized. So the structure of the Cloud-Optimized GeoTIFF is special. You have a specific metadata at the beginning. You order the internal tiles in a way to make request performance, and you can add overviews, and you can. But basically, it's still a regular GeoTIFF, just better organized, and thanks to the hard work that was made by others before me, like Evan, to create like a Cloud-Optimized GeoTIFF drivers and like all the libraries to create Cloud-Optimized GeoTIFF, and to think about how to optimize the GeoTIFFs. So I just show how it's, we've seen that before. It's usually easy to create Cloud-Optimized GeoTIFF. The pain of creating Cloud-Optimized GeoTIFF is usually to install GDAL on some systems. But like now with Docker, it's pretty easy to get GDAL. You can get GDAL on all the cloud processing services, on AWS Lambda, on ECS, on Azure, on Kubernetes, on most of the processing system. And so, but then when you have GDAL, like it's really easy to create a Cloud-Optimized GeoTIFF. You do GDAL translate of COG and take your input COG and your input TIFF and get a COG at the end. You can pass different options to that to make the Cloud-Optimized GeoTIFF as you wish. If you can use Python, you can use Java, you can use R, the GDAL bindings of GDAL to do that. You can also use Rasterio. So the CoGeoTIFF Rio CoGeo Python module is based on Rasterio. Rasterio is shipped with internal wheels, GDAL wheels. So usually it's pretty easy to do just pip install Rasterio. Maybe on some system again, it might be difficult on some Windows version, for example, on some Linux or like the new macOS ones. But like the Rasterio developers are working on getting the wheels for most of the people. So just do pip install Rio CoGeo, and you get a command line to create a Cloud-Optimized GeoTIFF with almost the same options for GDAL translate. And as we saw before, there is also the great Cogger Go library that lets you do like nice things to create a Cloud-Optimized GeoTIFF. So the COG, what makes the COG special? COGs are different features. You can choose the internal compressions of each internal tiles, and you can choose also a different compression for the overviews. And again, you have the overviews. The overviews are not required by the specification, but like if you plan to do any kind of visualization from Cloud-Optimized GeoTIFF, like large-scale processing without having the need to load all the data, all the raw data, all the raw resolution, overviews are a must-have feature. It doesn't really increase much the data storage, and it's pretty nice to be able to just visualize or get an overview of your data without having to download the whole raw resolution. The one important feature of Cloud-Optimized GeoTIFF is the internal block size that you can change. You can you can have big block size, small block size. I'll go in the deeper later on that. You can also have no data, or like a way to describe the no data value, the no data part of your data, using either no data value, an alpha band, or internal mask. And you can set, you can have a lot of metadata within the Cloud-Optimized GeoTIFF, as usually the GeoTIFF. And for the COG, something that is used more and more, it's the way to have the Cloud-Optimized GeoTIFF aligned to a tile matrix set grid. So if you only plan to use a Cloud-Optimized GeoTIFF in the web visualization using only the web Mercator grid, like it's easier, it's better to align the Cloud-Optimized GeoTIFF to the grid, so you reduce the number of requests that you will need to do, for example, to the COG to display the data. So I hope it's easy to create Cloud-Optimized GeoTIFF. It's also easy to use them. Like all the system, all the software that support GeoTIFF support Cloud-Optimized GeoTIFF. They might not support like some optimization, but at least you will be able to visualize, read it, and analyze your Cloud-Optimized GeoTIFF. But tools like GDAL, Rasterio, GeoTIFF.js, and other libraries are really optimized to get the most of the Cloud-Optimized GeoTIFF, and by like enabling like range requests, for example, just to read the small part that you need of your Cloud-Optimized GeoTIFF. So there are plenty of tools. You can find them on cogeo.org. And so when there's thinking, a lot of people usually ask me if Cloud-Optimized GeoTIFF is the best format. I usually say yes, it's the best format, because you get the compatibility with all the software that support GeoTIFFs, and you can choose whatever compression you want, so you can optimize the storage. You get fast read because you get range request reads of Cloud-Optimized GeoTIFF. And yeah, again, it's just a GeoTIFF, so it's really compatible for a lot of things. But it might not fit your use case. Something that really that's something you can't do easily with Cloud-Optimized GeoTIFF. You cannot update a COG in place. You cannot change one part of your data. It's really complex, because as soon as you change one byte of your data, you change the whole structure of your file. So you need to rewrite the whole file, and so that's why if you need like a file that is constantly updated, like Cloud-Optimized GeoTIFF will be really hard for you to work with, because you will have to read the whole file and to rewrite the whole file every time. If you need more than 3 dimension, if you need like temporal dimension in addition to spatial and maybe multiple bands, like it won't really work easily with Cloud-Optimized GeoTIFF. If you need also ultra fast tile service, you will be better off using like regular predefined tiles. So Cloud-Optimized GeoTIFF is a great format. but it might not just fit your use case. It's a great file format, like for a lot of things. Like usually it will fit like 90% of your use case, but sometimes it just won't. So now let's go and see how to work with the Cloud-Optimized GeoTIFF. So as I say, you can use GDAL to get information about your COGs. You can translate the COGs. You can create COGs using GDAL Translate. Other libraries, as I said before, COG is a great tool to create, get info, or also validate Cloud-Optimized GeoTIFF. Some other tools that I will use during this tutorial is RioViz, which is a command line tool and that brings ttiler in your local computer and to enable like visualization of your Cloud-Optimized GeoTIFF and just play with your Cloud-Optimized GeoTIFF locally and play with the different bands, like understand what is your Cloud-Optimized GeoTIFF. Another tool which I usually use is TileBench. So it's a development seed project which enables us to debug like the number of GET requests you will do or the number of data transfer that you will do on every tile request when you are using Cloud-Optimized GeoTIFF in like a web visualization framework. So it's really interesting to be able to understand how much data transfer you will do every time you need to read a tile to create a map tile, for example. So let's talk about compression. So there are a lot of, if you go on the GDAL web page on the Cloud-Optimized driver, there are a lot of options for compression. You can use Deflate, JPEG, WebP, LZW, ZSTD, JPEG XL, as Thomas talked about. So there are a lot of options. Most of them like will answer your needs. And I'll just talk about like a few options. Like for example, if you have a byte data set, and which is like one band or three bands, you will be better by using JPEG compression. Yes, and you can adjust the number of loss that you can allow, but you'll get a really small file. If you don't really care about like if you allow some loss, so some change of the data, but like JPEG or WebP and JPEG XL is also another option. Is a really nice compression. You'll get really small file and with few loss. But if you only use your COGs for visualization, that's maybe like that will be mostly you will be really happy with the compression. Like you can get really light files using that. If you have more than 3 bands, I think you can still use JPEG XL, but you will be better served with Deflate or LZW, other compression schema. And that might not be like 100% true, but for other data type, you will be better. You'll use usually Deflate, LZW or ZSTD compression. So just be aware, some compression schema are not supported by default on all softwares. For example, WebP, the WebP compression is not supported by default by GDAL. You have to tell GDAL you have to compile GDAL with WebP to be able to open a Cloud-Optimized GeoTIFF with WebP compression. So just be aware of that. Like you can create a nice and light file using WebP or JPEG XL, but if the customer doesn't really have all the drivers on his processing machine, like he won't be able to open COGs. So, but usually it will work with almost all the other compression scheme. So just an example of how small you can get your COGs using compression. So a non-COG data will be like, for example, for this kind of data, it's a byte data set. You get data which is natively 232 megabytes. And if you use a simple deflate compression, you'll get like more than half of the size. And if you use JPEG, because you might need this file just for visualization, you get like only a file that is less than 20 megabytes. So it's really, the compression is really important. Like as soon as you create a Cloud-Optimized GeoTIFF, by default, I think GDAL applied the deflate compression, but you can really play with other compression to create the lightest and the better Cloud-Optimized GeoTIFF for your use case again. Again, another example using SAR data stored in Uint16. The original file is almost 1 gigabyte. When you just use simple deflate compression, it's half of the size. And so yeah, just don't forget to use compression when you create any Cloud-Optimized GeoTIFF, just to save some space on storage. And then because you compress every tile, internal tile, it will be also faster when you do the data transfer. The overviews. So when you create the Cloud-Optimized GeoTIFF, you have the choice to create overviews and to create some level of overviews. The overviews, it's usually goes by a power of 2. So the first overview is half the size of the raw data, and the second overview is a fourth of the size of the data, and so on and so on. So when you create a Cloud-Optimized GeoTIFF, you by default, I think with GDAL, it will create the overviews when you are using the Cloud-Optimized driver, and also with Ryoko Geo. So here we do GDAL info, GDAL info on the Cloud-Optimized GeoTIFF. We see that the original file is 5,000 by 7,000 columns, and we see that there are overviews, so half the size, and so on and so on. It will stop at one point when the overview is smaller than the internal tiles. So the internal block size is 512 by 512 for this file. So we will stop creating overviews as soon as we hit the block size, because the GeoTIFF block size will be always the same internally. So when you create like smaller overviews for this, in this example, like it will be almost the same size when uncompressed, so as the last good one. So there isn't really like a need, or it doesn't really make sense to create like overviews that are smaller, way smaller than the internal block size. So usually you can just let GDAL or Ryoko Geo handle the number of overviews for your files. So one really interesting thing is the internal block size. As I said before, you can play with the size of the internal tiles, and so by default, some people will choose 512 by 512. Depending on your use case, again, you could change that if you work with like dynamic tiling, for example. Just you want to create a visualization of your Cloud-Optimized GeoTIFF. You know that you are only going to use your Cloud-Optimized GeoTIFF for visualization and for using WebMarketer. So you will align the Cloud-Optimized GeoTIFF with the tile, with the internal tile, with the TMS grid, sorry, and you will choose the tile to match the size of the map tiles. So like if you are using 512 map tiles on the client, you use the same size for the internal block size. And so again, it really depends on your use case. case, but you have to know that you can play with that. And the implication is, so as if you, for example, you want to get a part of the Cloud-Optimized GeoTIFF, if you can, the smaller the block size is, the more chance you have that you will need to cross the Y dimension. So it's a bit complex, but GDAL is more when you get a range request of the file. GDAL is smarter if you want to get data that are in the X dimension. So GDAL will be able to merge the range request. If I was going to read only data that are in that is in the first line, like GDAL will only do one GET request. But as soon as I cross the Y dimension, like because it's like in the file, the data is just not subsequent in the Y dimension. Like I will need at least 2 GET requests. So, but if the internal tile was big, like maybe I would only do 1 GET request. So when you choose small tile request, a small block size, you have more chance to do multiple GET requests. And I show some example. I think, yeah, I showed some example just before, just after, like what the implication of the internal tile size in terms of GET range request. And so something that it's also good to keep in mind, the block size also has also implication on the output file, the file size, the resulting file size. So it's a small implication, but it's always good to know that the compression is applied tile by tile. So the bigger tiles or the smaller tiles you use, the overall file size will change on depending on the block size that you use. And yeah, so I use TileBench just to give you a small demo of the implication of the tile size. So TileBench is a small tools that yeah, you can see that. Okay. It's a small tools that let you examine, let you see what the GET request for each tile when you want to read a tile, for example. So I've got a file locally using a web server. So it's called a B5. Nothing fancy here. Okay. So what the TileBench does is it shows in blue it's the Web Mercator tile grid that intersect my data, and in red, the small square in red are the internal tiles of the file. So I can see that if I click, if I want to read this file, this tile, I will only use the data for this internal tile, the red one. But if I want this one, you will need to get the data from the top internal tile and the one on the bottom. So, and we would see that in terms of GET request. If I do a request there, I do 3 GET requests, and if I do that, I should get maybe not for this one because it's the first overview. Sorry, it's a bit complex, but there are 3 and 4. Yeah. So we do one more GET request because we do the tile here intersect with another tile, another line of tiles. So if so, that's what I was trying to say with the X and Y axis. So and in terms of data transfer, we can also see the difference. Here we only transfer 100,000 bytes, and here we transfer way more data because we intersect 1, 2, 3, and 4 tiles, internal tiles. So while here we only maybe intersect only 1 internal tiles. So that's using like a file that has 256 internal block tiles, but if I use another one with bigger internal tiles, so again, let's not use that. So now we see the red square, it's much bigger. It's much bigger, so there are less chance for me when I do a tile request, a map tile request, to intersect the tile boundary. So here I do, if I click there, I will only, I don't know why, okay. Oh, because it's the overview again, sorry. So yeah, I should do only few tile requests, so 2 or 3, depending on where I am. And so we can confirm that here we do more because we intersect the y-axis. But so because the tile is bigger, even we do less GET requests, we transfer more data because the internal block tile is bigger. So this is, you have also to keep that in mind, that you can choose bigger block size, but bigger block size means more data to transfer per GET request. And so, and smaller block size might means more GET requests, but lower less data transfer. And I think I've got a slide that shows that somewhere there. Sorry. Yeah, I'll share all the documentation on that to explain like the data transfer and the number of GET requests. So yeah, the internal block size is a really important feature for the Cloud-Optimized GeoTIFF, and you have to choose it wisely depending on your use case, and it can influence the speed of the access to your Cloud-Optimized GeoTIFF. Okay, so one other, to me, one maybe not the most important, but like a really important feature of Cloud-Optimized GeoTIFF, or like usual GeoTIFF, is the way to define the no data part of your data. Like when you have a satellite imagery, or like any kind of raster, there are often like part on the side of your data that isn't really the data. It's like no data area, and when you work in the visualization process, like I often do, like it's really annoying to see all the black around the data, or like sometimes within the data, while while it shouldn't be there. It should be no data. So when you create a Cloud-Optimized GeoTIFF, is the just double think before like putting any description for your no data value. And so as I mentioned before, you can define the no data value as a fixed value. So it's a no data value. So if you, for example, you know that every raster value of your data that equals 0 isn't really a data, you just say that the no data is 0, and you can like put more complex value. But there is the no data value. You can also use alpha band, an additional alpha band within the data. So it's a proper band, a mask band, alpha band, to indicate the transparency of your data. Or you can use internal mask, which is almost like the alpha band, but maybe more specific to GDAW. And so one example of like what I was trying to explain, like I was seeing the black value around the data, so we can see it on the small image on the right. So for this data, there weren't any no data specified. So we can see, I'm not sure if you see my cursor, but there is no data value set or no mask or no alpha band. So when you load the data, you will see a black value around the data, around your data, because GDAL, or in this case, GDAL has no way to know that the black value around the data isn't really something that you want to visualize. So then sometimes that's annoying when you want to mosaic data. You want to overlap data with other data because you will still have the black values, which is considered as valid data. Yes, so something that I've heard, the no data isn't in the GeoTIFF spec, or wasn't in the GeoTIFF, the initial GeoTIFF specification. So in terms of like creating data that really match the GeoTIFF specification, I think it was added by GDAL maintainers afterwards, but it's something that most of software will understand now, the no data values. So even if it might not be in the GeoTIFF, in the TIFF spec, like it's still like it should be mandatory to have no data value set in your file. Something to also remember: don't use no data value when you are using lossy compression schema, because you get something like is shown on the image. You get like artifacts because the JPEG compression will create like will just change a bit your data and might create like no data value, no data pixel values. And so when you are using lossy compression, you should avoid using no data value and maybe use a mask or like alpha band. All right. The metadata is like not mandatory in the Cloud-Optimized GeoTIFF, but it's a really nice thing to add, and it can influence the data. So for example, this is a NAIP data that was created a couple years ago, and the fourth band of the data wasn't properly tagged. It was tagged as the alpha band. And while the original data should have been undefined, or like because it's the nearest infrared data, and it's not the alpha band. But when you will load this data into your browser or into QGIS, it will consider the fourth band as the alpha band, and which will create like white patches, as you can see on the image. So the metadata, the metadata of the band metadata is not mandatory, but it will be at least mandatory to put the right tag for each band to avoid things like that. So if you have more than 3 bands, or if you have like really complex data, you can really easily add metadata within the data to describe your data and to make sure that something like that doesn't happen. I think this was fixed later, but yeah, that's something that a lot of people have seen in the past, the wrong alpha value.
I've had this. How do you fix it? Like if I have a file, maybe the one I demoed the COG stuff with, the one that Google Earth created for me has it wrong. Like what's like the options for how I change it?
Yeah, you need to update the metadata, and so to set to put undefined instead of alpha for the band color interpretation. Sadly, you have to rewrite the whole code, as I was explaining before. You cannot update a code; you have to rewrite everything.
Gotcha.
But yeah, you have to update the band metadata, the band color interpretation tag.
And you can do that with Grio or GDAL.
With GDAL, with Rasterio, and maybe QGIS too.
Cool. Awesome.
I lost my presentation. Okay, sorry. Yeah, metadata. And yeah, I've been maybe too fast. I'll answer a question after. Anyway, so one thing I mentioned before is an option in Cloud-Optimized GeoTIFF or in GDAL or in Rio to align the Cloud-Optimized GeoTIFF with the Mercator grid. So this, for example, this file, we see the red square that isn't really don't rematch the blue ones because it's not aligned. It's totally normal. But you can with GDAL or with Rio COG realign every internal tiles to the web to the TMS grid. So in this case, it's Web Mercator. And so you reduce the number of GET requests because normally, and I think we'll have a presentation about that later. Because the internal tiles match the Web Mercator grid, you can only do in theory you will only need one GET request to get the header of the Cloud-Optimized GeoTIFF and one GET request to get the data because it matched perfectly. So and we can see that. Yeah, I can also demo that. I've got the web. Yeah, so it's the same file as before, the B5 that is aligned with the Web Mercator grid. So the blue and the white matches. So normally I should purely do two or three GET requests. There was a slight bug in GDAL that I don't have on my machine locally, but we should only do 2 or 3 GET requests maximum. And it will be really fast. So right now it's really fast because it's locally, but so that's a way to reduce the number of GET requests when you want to work with a visualization only project. So when you want to align the Mercator grid and the internal tiles. So yeah, all right. So yeah, so maybe from this this presentation, something that you will get out is there are a lot of ways to create Cloud-Optimized GeoTIFF. There are a lot of options when you create Cloud-Optimized GeoTIFF. You can choose the compression, you can choose the tile size, you can choose the number of overviews, you can choose to align the Cloud-Optimized GeoTIFF to a tile matrix set grid. You can choose 3 different ways to represent the no data value. So there are a lot of options, but depending on your use case, usually you can arrive at one best solution for yourself. So as I was showing before, when you have byte data through RGB data, you might use JPEG because it will create really light data. If you have float data sets or elevation data set, you might use ZSTD compression because it's it's a LERC compression because it's one of the best for floating points data set. So there will be combination that suits your use case, but yeah, there are plenty. And that's really also something really hard for us building tools that use the Cloud-Optimized GeoTIFF because there are a lot of options. The data could be in byte, could be in integer, could be in float. There could be 10 bands. There could be 1 band. You could have scales or offsets to apply to your data. And that's referred to the tweet we saw before from the conversation with Tom. If you want to support Cloud-Optimized GeoTIFF in your client, it's not as easy because there are a lot of options for your data. but we try to orient the people to the best solution. So maybe one day it will be you could just drop your file in any kind of client and have the right visualization created, because the client will understand how the Cloud-Optimized GeoTIFF is made and why it's stored in float, and what is and how the client should transcript this file to be able to use it directly. So yeah, there are a lot of options that because there are a lot of options, sometimes there are bad COGs, and it's not really like I won't blame everyone like who made an error when creating COGs, because I've made like a lot of errors when creating COGs in the past. But I just showed two examples that really show that help you think about when you will create your COG. So for example, this file that I found on the Stack Index project is a tree canopy. I think it's a California vegetation canopy base 8. And so when I first loaded the file in RioViz, like it was great. It was great. It showed great because the data is stored in uint16. So it can cover like a lot of values from minus 30,000 to plus 30,000. And when I look in the file, deeper in the file, so we can do that. When we look in the file, so if I do RioViz, the file, it should open locally the file. I hope it won't be so slow. Okay. So here's the file. When I look at the value, when I click, I should get the value. The value, it's only like integers, like from 0 to 6. When I get the statistics, I see that the minimum value is 0 and the maximum is 6. So this tells me there is something wrong with the file. Like it's not stored as byte, it's stored as int16, but the data goes from 0 to 6. So maybe the data type for this file should have been something else. And we can also see the statistics, the more statistics of the file. And so using still RioViz, and we see that there are like 9 unique values, and they are all like really integer. So that's another thing that tells me that maybe this shouldn't have been saved as int16, but as byte. And because as byte, you could have also choose another compression scheme, and also like and it will have also, you will have maybe put an internal color map to it, so the data like looks great when you look at it directly when you load it in QGIS or in RioViz, for example. So that's something. Maybe the data was already in 16. That's why it wasn't changed when creating the Cloud-Optimized GeoTIFF. But it results something that it's really hard to use, or like you have to analyze the data and why it doesn't display as you wished, as you were expecting. So yeah, that's about the data type. So be really careful. If your data doesn't need to use int16 and can use byte, it should use byte. Another one, yeah, that's the one we saw before. It's the nape one. So we see that the white patch here just is telling GLM rasterio that there is an alpha value here, but when we look at the data, it's not. It's we can tell that it's the near data. So again, I'm going to use RioViz. So the tool RioViz, as I was explaining before, can help you like play with the data, change the bands that you want to visualize, and we find the white patch here, and we see that it's because the band value is 0, but so that's why it appears transparent here. I don't know why I can't get the color map, the statistics, but so yeah. Oh, okay, I tried to load too many things, so everything is broken. Anyway, so that's also something. Just make sure to have the right data tagged on the right metadata for your file, and because if we see that, but yeah, it will still appear transparent because it should be 0. Yeah, so that's almost it for me.
Awesome, thanks, Vincent. There's a few questions on the Gitter. I can help go through them. One for me first, just, you said there's lots of different ways to do things. What's the best place to get advice on COGs, like Twitter, Slack, like?
Yeah, so you can always ask question on Twitter in the COG, tagging the COG GeoTIFF Twitter handle, which I manage. We have a Slack instance set up. I will share the links after. I think it's in Twitter. I'm pretty sure it's in the Twitter handle. So, oh no, it's not. Okay, it's here. It's here. So, and I will be happy to add anyone else. Where is Gitter too? And yeah, also on all the repo that I'm managing on Rio Tyler and Rio COG, there are discussions set up there, so people can feel free to jump there. Yeah. And I will say that the GDAL documentation is also a good place to start.
Cool. Some other questions. Dean was asking, just to clarify, to update the metadata, you have to rewrite the whole COG. He asked if COG can use an external link to JSON XML to store metadata.
I would say no. You could put metadata in XML, but the idea of COGs is to be self-defined, so without using any external files. So before, for example, you could use like external overview, but the specification for COGs just makes sure the overviews have to be internal, because we don't want to have to request other files. So the COG should be self-defined.
Yep. Then there was a question, for Sentinel-2 with several bands, would it be better to use ZAR?
It depends on your use case. It's really depends on your use case. Like for analytics, ZAR is perfect because you have defined blocks and you will run process on each chunks. And so for doing analysis and temporal analysis, ZAR is a perfect format. But at the time when I think the Sentinel-2 data started to appear, the COG was the best format for both things, for the visualization and for the analytics. And I know that ZAR is catching on the visualization aspect of the things, but I still believe that COG is right format for most of the use case. It's not the best one, but it's like a good one for covering most of the use case.
Awesome. Let's see, there's a couple others. Yeah, how is it interleaving in COG? Like RR, GGG, BBB, or RGB, RGB? If I understood correctly, with the second, there was no optimization to read just a few bands from multi-band file. I'm thinking of examples with 8 bands.
So the interleaving is, I think it's RGB, RGB, RGB. So it's a band interleave. So yeah, it should be RGB, RGB, RGB. it's RGB, then the overview, it's again RGB. Not sure if it makes sense for Javier. And
let's see, from Robin, interested in aligning to TMS. Should you not align to TMS grid if you're going to use COG outside of web mapping, e.g. if you want to keep all the data, all the raw data, does it basically reproject the COG to Web Mercator?
Yeah, if you are not going to use only for web mapping, your COG only for web mapping, I would say don't reproject things, because when you reproject, you create data. You change, you alter the data, and which is okay when you are only doing visualization, because you are not going to apply like scientific analysis on just the visual aspect of things. So I would say don't change the data. Try to keep the data as raw as possible. Just add overviews, but yeah, don't reproject the data.
Cool. Let's see, one more, and then I think we'll shift to the next one. How do you enforce the metadata recommendations you're making when creating COGs? Like, does it scale, or do you have to manually check and analyze each file as it's created with something like RioViz?
It's a manual process. I mean, for the alpha metadata, for the color interpretation, for your interpretation tag, there are only few tag allowed. So GDAL will tell you that you are trying to do something which is not good. But like you could tell the GDAL that it's a RGBA, as we saw, it's a RGBA data while it's RGB near. So there is no really way to enforce. It's up to the user to know what data he has and what to do with that. Oh, and I think Ivan say that you could preserve the COG structure, so you don't have to rewrite the whole COG, just doing the edits for the color inter. Oh, no, you still need to use Cogger afterwards. Anyway, sorry.
Awesome. Cool. Thanks so much, Vincent. This was super awesome. Lots of knowledge. I think this will be a really good tutorial for people to look back on and learn a whole lot. So yeah, thanks for taking the time to do this. And I think with that, we're going to transition to the next talk.